Hello and welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 3, Lesson 11 on the angle sums in a triangle. So for years, right, you've been learning things about the way the three angles of a triangle add up together. Today we're going to prove it. And we're going to prove it using things that we've learned already from rigid motions, right, and transformations in general, as well as parallel lines. So let's get into it right away, and let's do some review of two extremely important ideas that we're going to need in this lesson. Let's take a look at exercise number 1. In this exercise, we will review two important ideas needed for this lesson. Letter A. In the diagram shown, points A, B, and C are collinear. Rays BD and BE have been created to form angle 1, angle 2, and angle 3. What is the sum of the measures of angle 1, angle 2, and angle 3? So what do they equal when you sum them up, and why? All right, so this should not be a tough one for you. What I'd like you to do is take a look at this diagram and tell me what you get when you add the measure of angle 1 to the measure of angle 2 and the measure of angle 3. Put that in here, and then if you can, write down some kind of explanation for why you know that that's their sum. Take a moment. All right, well here it is, right? By adding up those three angles, we should get 180 degrees. Even though we don't know what the measure of any one of those individual angles are, we know that angle 1, angle 2, and angle 3, when put together, form the straight angle ABC, right? So the y is together they form a straight angle, right? And all straight angles have measures of 180 degrees, so angle 1 plus angle 2 plus angle 3 must be 180. Now, side note, one of the keys in that is the fact that A, B, C are collinear, right? If A, B, and C didn't lie on a straight line, right? If they were tilted a little bit, then we wouldn't know that angle ABC was a 180 degree angle. But since ABC all lie on the same line, they've got to be a straight angle, which means 1 plus 2 plus 3, angle 1 plus angle 2 plus angle 3 must be 180. All right, let's now take a look at another important piece, another review piece in this problem that's actually not connected to letter A. Let's take a look at letter B. In the diagram shown, lines M and N are parallel and crossed by transversal line R. Which of the three angles, angle 2, angle 3, or angle 4, is congruent to angle 1? All right, so we've worked a lot with parallel lines. You know, we even saw them in the last lesson. One of these three angles, 2, 3, or 4, is congruent to angle 1. Which one is it, and also why? Pause the video now and take a shot at this. All right, well, hopefully you said angle 1 and angle 3. So angle 3 is congruent, which means it has the same measure to angle 1. And this is because they are alternate interior. Alternate interior angles are possibly the most important types of angle pairs created by parallel lines, right? Now, it might be a little bit difficult because of the way this is oriented, but, you know, obviously 1 and 3 are interior of the two parallel lines, and they are on opposite sides of that transversal, so they are alternate interior angle pairs created by parallel lines. They must have the same measure. They must be congruent. All right, let's keep going with this and see how we can figure out what's going on with the angle sums of a triangle. Exercise number 2. Side AB of triangle ABC lies on line M below. Do the following. Letter A, translate triangle ABC along M so that point A maps to point B. Label the image triangle BDE. All right, this is simple enough. All I want you to do is take tracing paper, put it over this diagram, make sure to draw out line M, make sure to then copy line A or triangle ABC and then just translate this triangle along so that point A shifts over to point B. You don't have to then label point B as A prime. We're just going to say that B is the image of A after this translation. But then you should label the other 2 points D and E. Go ahead and pause the video right now and do this translation using tracing paper. All right, let's go through it. So I've kind of drawn it all on tracing paper. I then just simply translate this thing over until point A goes to there. And now it's going to be triangle B, D, E. All right. Now I'm just going to leave it like that. Again, you should redraw this. Now, letter B. Let's take a look at that. Label each angle in the image triangle as angle 1, angle 2, and angle 3. All right, a little bit of grammar there. But so in other words, right, we know that a translation is a rigid motion, right? And because it's a rigid motion, this triangle is identical to this triangle. And that means that if this is angle 1, then this must be angle 1 as well, right? Likewise, if this is angle 2, that must be angle 2. And if this is angle 3, that must be angle 3. Again, rigid motions, translations being an example of one, do not change the measures of angles. So, if this is 1, 2, 3, this must be angle 1, 2, 3. All right, now letter C. Besides being the same length, how else are segments AC and BE related? All right, so because we've got a translation, and translations don't change the length of line segments, they don't change the measure of angles, AC got translated over to BE, they've got to be the same length because it was a translation. But there's another important relationship between segment AC and BE that's very particular to a translation. What's the relationship between those two? Pause the video now and see if you can write something down. Well, they've got to be parallel to one another. Now that is very particular to translations. In other words, when we translate a line or a line segment or array, doesn't matter what direction or how much, but when we translate that, it produces an image that is parallel to the original. We've seen that a couple different times. Now we're finally kind of getting to the heart of the matter. Letter D says, based on letter C, label another angle that must be congruent to angle 3. Verify using tracing paper to check. So let's talk about this a little bit. My claim is that there is another angle up in this diagram that you can also put a 3 in. That you can say, hey, this angle is the same as angle 3 based on the fact that AC and BE are parallel to one another. Which one of those angles is angle 3? Don't worry about this down here. This is just my tracing paper that I've traced out like angle 3 on. See if you can figure out another angle that is congruent to angle 3. Pause the video now. All right. Because these are alternate, because this is parallel to this, if this is angle 3, this must also be angle 3 as well, right here. Because these two angles are alternate interior. I can't get my pen to draw there, right? They are the angles that are created by the Z. Think about that last exercise we did. This is almost the exact same diagram. If that's angle 3, that must be angle 3 as well. And we can verify it, right? Here's our angle 3. Now, if I want to make sure that this angle is the same as this angle, whoops, that's not what I wanted to do. Let me just pull this one over. I am going to have to rotate this thing about 180 degrees. Not about, exactly 180 degrees. But then it fits just perfectly in there. Get that out of there, right? So we can see that this angle must be angle 3 as well. So I've got angle 2 here, angle 1 here, and angle 3 there. Awesome. Let's take a look at letter E. What does this tell you about the sum of angle 1, angle 2, and angle 3? What must be true when we add up the measure of this angle, and this angle, and again, concentrate on the fact that here's angle 1, here's angle 3, and here's angle 2. What do those three have to add up to? Pause the video now and see if you can write something down. Well, they must add up to 180, right? They have to add up to 180 because here is that straight angle, right? And that straight angle is comprised of angle 2, angle 3, and angle 1. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 must be 180 degrees, all right? And that is true of all triangles, all right? All triangles, you can do exactly this demonstration on. And we're going to do it with two more triangles in just a moment. But you can slide that triangle over, you can reproduce the three angles, and then this angle will always be the one from up here, showing us that those three angles, when combined together, give us a straight angle or 180 degrees. All triangles that are drawn in the plane have angles that sum to 180. Now, I know you saw that before in Math 7, and you may have even had Math 6 teachers who pointed it out to you. But here we finally see how to prove that it's true by using a translation, which then retained the angle measures, and the fact, and this is absolutely critical, that a translation also makes this parallel to this, which means that angle must be equal to that angle. So all three of those angles then sum up to 180. Let's take a look and see this in another diagram, right? So you could say to yourself, well, maybe it was just the particular diagram. You know, maybe it only works with those kind of triangles or those kind of triangles. Let's take a look at exercise 3. The demonstration in exercise 2 was reproduced below for A, an obtuse triangle, and B, a right triangle. Label all relevant angles as angle 1, angle 2, or angle 3 to show that the three angles must sum to 180. All right, so here's what I mean by that. You know, here I've got an obtuse triangle and I did exactly the same thing. I just shifted it over to here, right? And because it's simply a translation along this kind of line, ABC, then what I know is that I know that this angle must be 1, this must be 2, and this must be 3, right? That's just simply true because it's a rigid motion. But because I know that this segment and this segment are parallel to each other, then that creates an alternate interior angle pair that says, if that thing's 2, this must be 2 as well, right? And because I now have angle 1, angle 2, and angle 3, this shows me that they must add up to 180 degrees. Why don't you do that labeling on this diagram as well? And that's all you have to do is do the labeling. Pause the video now and go ahead. All right, so we've got angle 1, angle 2, angle 3. That means this must also be angle 1, angle 2, and angle 3. Again, we've got that alternate interior angle pair. That's angle 1. This must be angle 1. And that means all three of them, 1, 2, 3, must add up to 180 degrees. By the way, you may have noticed, as I just did, that not only do you have angle 2 and angle 2 here, but you also have angle 2 and angle 2 here. It's almost like these two are also an alternate interior pair, and they definitely are, because BD is parallel to BC, and again, you get that like Z action going on, right? So that like kind of Z here, where that angle and that angle must be congruent. Same thing over here, right? We've got this parallel to this, which would make this and this alternate interior angle pairs. Isn't that kind of cool? Now, the big takeaway from this is real simple, right? Triangle fact. For any triangle, its three angles have measures that sum to 180 degrees or a straight angle. That will be taken as fact in every kind of problem from here on out. In geometry, we are now going to assume that it doesn't matter what the triangle looks like. It doesn't matter whether it's a right triangle, an acute triangle, an obtuse triangle, an equilateral triangle, an isosceles triangle, or any other type of triangle, a French triangle even. It won't matter. the angles will add up to 180 degrees. We can now use that in a variety of different problems. Let's take a look at exercise number 4. In triangle ABC below, the measure of angle C is 120 degrees, and the measure of angle A equals the measure of angle B. Find the measure of angle A, show how you found your answer. All right, so this is a very, very kind of common problem. Here we've got the measure of angle C is 120 degrees. Okay, that doesn't really look like a 2, but let me take another shot at it. Looks like a very funky 2. That's not much better, but it gets the job done. So we have 120 degrees. What we want to know is we want to find the measure of angle A, and we've been told that A and B have the same measure. Well, all we have to do is just keep track of those 180 degrees, right? They're always going to add up to 180. So I can say, well, I've got 180 degrees minus 120 degrees, which is 60 degrees. All right, so I've got 180 total to play with, and 120 of those 180 are sitting right there. Now that 60 degrees has to be divided up evenly between angle A and angle B, only because they told me the measure of angle A equals the measure of angle B. So if I want to know what the measure of angle A is, I simply just have to take 1/2 of 60 degrees, and that must be 30 degrees. And that's it, right? Now again, if we didn't know that the sum of the angles of a triangle was 180 degrees, we could never do this first step. We wouldn't know this, which would make everything else impossible in this problem. Let's continue to see how this fact plays out in various angle and triangle problems. Exercise number 5. In the diagram shown, AD and CE intersect at B. Triangles ABC and BDE are drawn with the angle measurements shown. Is the measure of angle C greater or less than 100 degrees? Justify your response. All right, well, there are 2 triangles in this figure, right? There's obviously triangle ABC and triangle BDE, however you want to name it, right? We've got this 65-degree angle, we've got that 90-degree angle, and we've got that 52-degree angle. And ultimately, all we're trying to answer is whether the measure of angle C is greater than or less than 100 degrees. What I'd like you to do right now is pause the video and try to fill in any angles you possibly can, given the fact that the sum of the angles of a triangle are equal to 180 degrees. Go ahead. All right, well, ultimately, if we want to get one missing angle in a triangle, we need to know the other 2. So if I concentrate on triangle BDE, I know I've got a 90 and I've got a 65. So if I'm just looking at triangle BDE, right, then I could take that 90-degree angle, and we have to know that that's what that symbol means, and I could add it to that 65-degree angle, and I would get 155 degrees. Now I know that triangle BDE must have a 180-degree sum of its angles, and therefore I can figure out that the missing angle in that triangle is 25 degrees. Okay? Now the question is, how do I make the jump over to this triangle, triangle ABC? Well, one thing that we learned, and it was a little while ago, was that vertical angles, or 2 angles that are created by crossing lines, those angles have the same measure. Meaning that if this is a 25-degree angle, this is also a 25-degree angle. There we come on to. That's not happening. We're going to try that again. That is a 25-degree angle. All right. Kind of shoved in there. It's a small space. Anyway, now, as soon as I've got my 52-degree angle and 25-degree angle, I can then pull the same business I did here to figure out what angle C is. So let me now play around with triangle ABC, right, where I know I've got a 52-degree angle plus a 25-degree angle. And of course, you could certainly do a lot of this on your calculator, but as much as you can in your head, that's good. So that's 77 degrees. Now I can take 180 degrees and subtract the 77 degrees, and I get 103 degrees. that means that's got to be what the measure of angle C is. It's got to be. Because we know in triangle ABC, the three angles must add up to 180. So when I add my 52 and my 25, I get my 77, subtract that from 180, and that leaves me with 103. So now I can answer the question, because the question was angle C greater than or less than 100 degrees? And we're going to say greater than 100 degrees. All right. It's what I call fill in the missing angle. And if you don't know in a particular problem where to start, fill in any angle you can. So if you see a triangle that's got two angles given, add them together, subtract that sum from 180, and fill in that third angle, and go from there. That's really what I did in this problem. I saw the 65, I saw the 90, I added them together, got 155, subtract from 180, get 25. That allows me to make the leap via vertical angles being equal, that must be 25, and then eventually I got angle C. Let's try to use this in one more problem. Let's get a little algebra involved. Exercise number 6. In triangle ABC below, measure of angle B is 38 degrees, and the measure of angle A is 10 degrees more than the measure of angle C. Find the measures of both angle A and angle C. All right, this is an ideal place to use algebra, but I don't want to crimp your style with algebra or anything else like that. What I'd like to do is ask you to pause the video now, try to figure out what the measure of both of those two angles are based on the information given, and then we'll go through the problem. Go ahead. All right, let's do it. Now, here's where I talk about it being ideal for algebra, right? So what I know is I know that angle A is 10 degrees more than angle C. So what I'm going to do is I'm going to actually let the measure of angle C be equal to x. All right, my favorite variable, x. Y is really upset about that, but I don't know why. All right, so let the measure of angle C be x, all right, and if the measure of angle C is x, then the measure of angle A, which is 10 degrees more than C, must be x plus 10. Now, what's really great about that being x plus 10 is that I can now take the three angles, add them together, set them equal to 180, and I can solve for x. So in other words, I'll get x plus 10, let's not forget this one, plus 38 is equal to 180 degrees. And now all I have to do is simply solve that equation, right? I've got x plus 10 plus 38 is 180. Simple enough. I can now combine these two x's. I'll get 2x. I can combine the 10 and the 38 to be 48. Set that equal to 180 degrees. Now I've got a nice two-step equation I can solve for x. I'll just subtract 48 from both sides. That's going to give me 2x is equal to 132 degrees. Right, I can now divide both sides by 2. 132 divided by 2 gives me 66 degrees. That's going to be the measure of angle C. And the measure of angle A is going to be 66 plus 10, or 76 degrees. One of the great things about this particular problem is that I can simply take the 66, the 76, and the 38, add them all together as a great check. And if I do that, I'll find that I have 180 degrees. If I were to add up those three angles together and I didn't get 180, then I would know that I made a mistake either in my algebra or maybe just in the setup of the problem. All right, let's wrap this up. So you've probably known, at least for a couple years, that the sum of the angles of a triangle will always equal 180 degrees. In this lesson, we proved it. And we proved it by using special properties of translations. One, that translations are rigid motions, so they don't change the measures of angles. And two, translations also map line segments to other line segments that are parallel to them. This allowed us to then do that demonstration to show that no matter how you do that translation, you'll always find that the three angles will form a straight angle and therefore add up to 180 degrees. Once we have that fact, we can use it in a whole variety of different problems where we're essentially looking for missing angles in triangles. Now, whether that's like using algebra in the last problem or just doing some arithmetic in the previous ones, the basis of all of it is knowing that the sum is 180. All right, well, we'll certainly use that fact a lot more as we move forward. For now, I just want to thank you for joining me for another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.